Let's look at another function in our library, is the squaring function. Guess what the squaring function does? It takes your input value and it squares it, so you have this guy right here. Make a t-table of values so we know what this shape is. Now if I were to plug in, say, -2, -1, 0, 1, and 2, the most basic x values that you would plug in here to get an idea about what's going on. With these guys, since they're not always linear, you have to plug in several values so you can get an idea about their shape. If I plug in -2, what do I get? Plug in -1, I get what? Positive. When I plug in 0, I get 0, then 1, and then I get 4. Do you all agree?
Yes.
If I plot these points, I get -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Now, this guy says that every number you plug in, you're going to square that guy. So if I plugged in 3, what would I get?
9.
Plug in 3, I get 3 squared, which is 9. Plug in -3, I get -9. So I get all these points here. And you'll see that this is not a line, but it's a curve. And so I expect you to make a nice, smooth curve going through these points. Do not disappoint me. Because if you do, then I'll have to treat you like the henchman, and I'll be like the evil, like the supervillain. Henchmen are disposable. You screw up, you're gone. I'll get another one to replace you. So what is the shape of this guy called? Do you remember? This is a parabola. And what we're going to see later on is that there are a lot of neat things about this guy. You have this minimum point right here located at the origin, but what's it called? This is called the vertex. And then there is this imaginary line that runs through the middle of this guy, through the vertex, and what is it called? This is called the axis of symmetry. Okay. It's called the axis of symmetry. What you have on one side of this axis, you have on the other side. There is symmetry about this line, and that's something we're going to talk about in the next section. Symmetry based on the y-axis, x-axis, origin, or maybe there are other lines of symmetry. And the neat thing about symmetry is that once you know half of it, you just have to reflect it accordingly and get the other part of it. When I look at what the computer has drawn, you see I get the same thing. All the key points match up. Here's my vertex. I've got my axis of symmetry running down the middle. Everything's perfect.